So our first presenter for the afternoon is Dr. Harry Kamilaris, and he's a senior business development consultant for Agricarbon. So take it away.
Thank you very much.
And just so you know, this is the time that he wanted to run through smoke and have fireworks coming out. So just envision that, because we didn't get that right for him. So sorry, Harry.
Maybe we'll get it next time. Right. Thank you very much. So thanks everybody for coming and thanks for joining for this session. So my name is Harry Kamilaris and I work for a company called Agricarbon. I work as a senior business development consultant and I have over 10 years of experience in the sector of sustainability, and I'm here to present and to help you and highlight what the value that is actually beneath the grass. So let's uncover the role that soil carbon plays in dairy farming. Now, in terms of content, right, I'll just give you a quick taste of what's to follow. So the first thing is we're going to have a quick look of what's the situation today in the industry. Then the next thing is I'll introduce a bit of our company and what we do and how our solution can help you. Then the juicy bit comes where I will share insights from a case study with First Milk, and this is very interesting because this is one of the most intensive and extensive, as you will see, soil carbon analysis exercises in the world. And then the last bit is I'll put this into context into why is this important for you. So Before I start, I just want to share a very quick story. So yesterday I was preparing for my presentation and I came into this article that says what is important for dairy company executives. So what gets them excited? So I got a bit worried because the first thing was innovation, second thing was new ingredients, growth. So I thought, would that be relevant? But then the next table was about what keeps them up at night, right? And number one was sustainability. So I said, yeah, that's spot on. That's the right thing for the right audience. So yeah, hopefully I will give everybody something that will help them sleep a bit better at night with our solution. So first things first. So what is the challenge, right? Everybody knows that this is a very, very worrying and strange time for dairy industry, because dairy is under a lot of pressure to set, first of all, and then deliver on environmental targets, reaching net zero. So with every challenge comes an opportunity, right? And what is the opportunity? The opportunity here, as we see it, is to take ownership, right, and understand the role that soil carbon, that's under grasslands, right, could play in natural climate solutions. So what is this role? What is the role of soil carbon? So three main things that I want you to remember, right? First thing is it has a huge role to play in climate mitigation strategies, right? So climate change mitigation strategies. So what does that mean? Through soil carbon sequestration, there is a huge potential of actually going beyond reductions, because we heard a lot about reductions, reducing emissions, ESG targets yesterday. We heard a lot about that, but this is one step further and actually removing CO2 from the atmosphere, putting it back to the soil. Very, very, very straightforward, using the most natural thing, which is growing trees, growing plants, right? So first of all is the ability of soils to increase carbon and sequester. Second thing is productivity, right? So soil carbon has a huge role to play. So increasing soil carbon means increased yields, means increased biodiversity, right? So looking at the holistic picture, and increased availability of nutrients, right? And then the last thing is building resilient systems. So building more carbon into the soil means reducing soil erosion, means increasing water holding capacity, and that actually leads to climate resilience. So building systems that are there to last, that are sustainable. Now, how to do that? There's two avenues, right? First thing is the potential of certain practices, farming practices, to increase the soil carbon. And then the second bit is sustainable management practices to keep it there, to keep it in the soil. Now, this is the opportunity, and what is the solution? So how can we actually take advantage of that? So what we need is robust and auditable data, right? So we need to measure and we need to monitor what is happening. And this solution needs to be accurate, right? It needs to be high integrity, cost effective, because we're talking about huge hectares and huge amounts of land. And then the third thing, it needs to be scalable and future-proof, because this is very much a live science, you know, when you talk about environmental science, and a lot of things change, so it needs to be future-proof. Now, this is where we come in, right? So Agricarbon. So what we do is we measure, right? So we accurately and robustly measure soil carbon stocks at scale. And how we do it, it's very, very simple. So we start with, we come in, we measure, then you use different management practices, regenerative practices to increase the carbon. We come after a few years, we remeasure again, and this difference is what you actually removed from the atmosphere, put it back to the soil. So we provide an audit. We started in 2018 from Scotland, from Dundee, and now we have a global reach, right? So we provide audits that underpin the confidence in reporting environmental targets. And here is a snapshot of our clients, of companies that believe in what we do, and they understand that what we offer actually unlocks this global transition to regenerative farming. Now, why do you need direct sampling? Why do you need what we offer? There's three things to remember. First one is there is a high soil variation, right? So you can have one field that has various soil types. And when it comes to carbon, this has an impact as well. Second thing is there is a very small percentage of change over time. So even though if you look at the magnitude of change when it comes to across fields, across farms, across portfolios, it's huge. It's a huge change. The percentage that we're trying to detect is small. That's why we need to be very, very accurate. And then the last thing is this change needs to be statistically significant. And what it means is replace statistically significant with real, right? So it needs to be real, not just noise in the data. Now, how do we do that? So this is how we unlock the direct measurement at scale. So it's an end-to-end 4-step solution. And I will start a bit unorthodoxically describing it from the automated analysis. So this is the bit that happens in the lab. This is the main innovation. This is why we are here, something that was unthinkable a few years ago, maybe 5 years ago. Now it's possible, and it's possible at a fraction of the cost, because we have fully automated the analysis. So we give results on soil carbon content and bulk density. Second bit that we do is that we go out there and we sample, right? So we have a fleet of machines, ATVs, and field operators. And what they actually do is we have rapid, flexible, geo-referenced field sampling, and we can go up to 1 meter in depth. And I'll explain a bit later why this is very important. Then the other thing that we do is that we come up with a sampling strategy. And what this is it answers two questions. First is where we sample, and second, in order to capture the variation. And second thing is how many samples do we need in order to be able to say we can prove that this change that we detected is real. And then at the end of this process, you can have a very, very easy to follow report that is compliant with all the latest reporting standards. Now, you see the theory, right? How does this look in actual real life scenario? So this is some insights from First Milk case study, and First Milk is a dairy co-op in the UK with more than 2,000 members. So it's a very simple structure: challenge, solution, and next step. So the challenge was they set environmental targets. They wanted to be able to support the adoption of regenerative farming. The solution was baseline and monitor progress, right? And the next steps is use this data to inform decisions and then resample again after 5 years to monitor changes. Now, let's have a look at the numbers, because this is one of the largest, it's the most intensive and extensive, as you can see on the map, soil carbon survey of dairy farms anywhere in the world. So we're talking about 75 commercial dairy farms in the UK, more than 2,000 fields, 8,000 hectares. That gives us more than 20,000 cores extracted and more than 63,000 soil samples analyzed. And because these are real farms, there were different land uses. And what we will look is arable, when it comes to land use, ley, which is a temporary grassland from 1 to 5 years, and then permanent grassland. So this is at a glance the numbers of the study. Now the interesting part comes in, so let's try and look at the data and what it tells us. So the first thing which is important to note is know your soil type, right? So soil type plays a significant role when it comes to both soil organic carbon storage and the capacity to store more. And as you can see here, these are the soil types in the study. One of them was very low. This is because of the high content in sand. So there is a significant difference between the different soil types. Second bit that's important is you can look at the content of soil organic carbon percentage across the different land uses. And what you can see is that grasslands have the higher amount of soil organic carbon. And that actually means that there is an opportunity to manage grasslands efficiently and sustain it there and keep the carbon in the soil. Now, the third important thing is soil depth, right? So increasing the soil carbon stock is a vertical challenge as well. And the three important bits here, first is the depth. So the average soil depth was 50.7 centimeters, which is really important to understand. Second bit is that 28% of the total soil organic carbon stock was found below 30 centimeters. And why this is important? It's important because traditional soil sampling used to only look at the first 30 centimeters, and all the models only look at the first 30 centimeters. But this is leaving a lot of value on the table, right? So this is saying that I'm uncovering a treasure and there's 30% more if you dig a bit deeper and you're not doing it. So that is the second important thing. Third one is that there was more soil, when you look at the different land uses, there was more soil at depth in permanent grasslands than any other land uses. So what does that tell us? It tells us that we need to sample that depth. So we need to go below 30, we need to go 50, 60 centimeters in order to capture the whole value. Now, this is a really important slide, because what it shows is that, okay, we understood the difference in soil types, we understood the difference when it comes to depth, we understood that there is soil carbon in there already. Now, what is the potential of adding more? What is the potential of sequestration, of building more carbon into the soil? Now, first thing is land use change. You see this transition, right? So if you go from arable to ley, from ley to permanent grassland, there is a huge change in the soil organic carbon percentage. We're talking about 12% from arable to ley and 11 from ley to permanent grassland, which is, if you look at the whole portfolio, it's an incredible change. You're building a lot of carbon. Now, the next graph is equally important because it looks beyond the transition and it looks on management change. So what happens in a lay and in a grassland field, you have a wide range, and this wide range illustrates opportunities, right? So yes, soil types are very important and they play a role, but there are fields with 16 that could go to 100, that could go to 300. So that's a huge opportunity of different management changes that could help build more carbon within the same land use. So what is the story that the data tells us, right? So looking at this amazing, this really informative sampling exercise. So the first thing is that it is possible, right? It is possible to baseline and monitor at this scale. And you can do it at a really efficient cost, and you can do it at the very valid with scientific integrity data. So it is now possible. Second thing is that know your soil types, right? This dictates both the capacity and how much they can increase. So really important to understand the soil type. Third thing is that there are practices, sustainable grassland practices, that you can maintain the high soil carbon within the grasslands. And then depths are important, right? So capture changes of depth, especially because more soil carbon is at depth in permanent grasslands. And then the last bit is there is a great range, right? So management changes in grasslands can increase soil carbon stocks, and taking the opportunity to look at management changes, the key point for all of you is that it's really important to capture the data on management and capture the data on management changes, because this actually puts all this data into perspective, right? And you can understand what works, what doesn't, and what's a good practice. So really important to be able to capture the data. Now, last slide is why is this important for you, right? Where is the opportunity, right? So the opportunity here is to develop a very robust baseline, right? That you can confidently demonstrate that you are doing steps towards a global environmental sustainability. So develop a baseline, be able to monitor change, and be able to confidently say that I am doing it and this is what I'm doing. Now, the additional benefits is that you can do that by improving soil health as well. You can look at regulatory compliance as well, so stay ahead of current and future environmental standards. Third thing is look at having high integrity data that help with decision making. And then the last thing is market differentiation, right? So you can stand out by adopting real and verifiable sustainable measurements and practices. So I want to thank First Milk for providing the data, and I want to thank University of Leeds for looking at the data and managing and kind of like there's so much more we can do, but these are the first conclusions that are coming out. So I want to thank First Milk and University of Leeds, and I want to thank all of you for coming today. And yeah, thank you very much.
Well, you don't get off quite so easy. We have got some questions for you. So it looks like we've got a couple questions out there. If you didn't type them in, wave your hand and we'll come find you as well. My colleague Alfred has a mic, and so do I. Which one would you like to tackle first? How about this one? How can you explain that there was such a low amount of carbon in some permanent grasslands?
Yeah, no, that's a really good question. The first thing is the complication that comes in with the soil type, right? So arable is usually, and it only makes sense to be at the best land available, right? So you can look at the differences through the lenses of different soil types in grassland. So that's the first thing. The second thing is different management practices. So what we did, and what I didn't show you, is these results have a bulk of different management practices together. Now, if you try to untangle them, and that's why I say it's key to record data for management and management change, then you will be able to see where it makes more sense to focus and when it makes more sense to put your efforts to add more carbon. So these three things, I think, is what kind of like gives us these results.
What practices should farmers adopt then to increase carbon in the soil?
Yeah, again, another great question. So there's plenty of things you can do. It's all under the banner of sustainable or regenerative practices. Now, it really depends on the system, but you know, if there's, for arable system, there's cover crops that you can do, minimum tillage, or if you look at grasslands, you can move from set to rotational grazing or to multi-paddock grazing. There's plenty of things you can do. And the main thing is to get the baseline, understand what's there, and come up with a carbon management plan that will help you build this, the stocks.
So I'm going to go a little off script here and ask you a question that came up only a month and a half ago in the United States, and we were at a soybean growers event. And what you're talking about going in now, measuring a baseline, and figuring out where we're going from there. What about, you just mentioned a couple of the top, I would consider them the top 2 ways in which to increase, you know, carbon in the soil. And what do you say to farmers that have been doing that for decades? And now, are they going to be penalized because now their baseline is here instead of where other people are here? How do we address that topic?
Yeah, I mean, that's a really good question that actually kind of like goes through everything, right? When it comes to building soil carbon or when it comes to emissions, you know, where do you set your baseline, and do you actually penalize people, farmers that have been, you know, doing the good thing? But my view is when you get the baseline, you can clearly see that, right? So you can clearly understand who has been already, you know, working with sustainable and regenerative practices, and there should be incentives of actually, as I said, sustaining it. So there should be incentives of maintaining the carbon into the soil. So there are plenty of ideas. So maybe you can baseline an area, and then you can actually look at how the different farms in the area are performing according to that baseline. There are plenty of things to do, but you're right, this is a very heated discussion in the States and in Europe as well, so yeah.
So the next question that we have is in measuring percent carbon footprint per liter of milk, and looking at what kind of carbon savings.
Yeah, so that is a really hard question to answer, right? So you would need the farm carbon calculator, you would need an LCA analysis, but in principle, if you look at the carbon footprint, you're talking about emissions, right? So when you would look at what we are talking about, soil carbon sequestration, this would be, the emissions would be the post, and then this would actually drop the number of your carbon footprint. So it really depends on the scope and on the level, right? The percentage that you can save and what would result in the footprint per liter of milk. So this is actually an exercise that is a bit more tailored to the land and to what you're actually trying to achieve. So there is a clear benefit, right? Because, you know, there's emissions, there's sequestering emissions, there's a clear benefit, but it really depends on a case by case.
Are there any questions from the audience? Alfred, I think we have one up there.
Thank you so much for your nice presentation. I promised some questions, so I asked a question. I understand that getting more into the data analytics and be more precise will bring some more differences, you know. But I was wondering, because that comes with a cost, of course. How much value is in this precise or more precise measurement compared to the conventional way? And who should pay for it? Is it doable?
Yeah, so thanks for keeping true to your word and asking the difficult questions. So two things here, right? So when it comes to precision in the data and the extra money, right, and the extra cost that you incur, the one thing to remember is that when it comes to carbon, right, the actual metrics have an uncertainty along, right, and this reflects to the final value of the carbon. So even though you incur some cost in the actual measurement, what you are doing essentially is you're reducing the uncertainty at the final number. So what that means is that yes, you need to have high quality data in order to have a value that doesn't have a high uncertainty number with it. So in terms of cost-benefit analysis, it makes a lot of sense. And there are many companies, unfortunately, that jumped into doing analysis with different ways, you know, doing the W analysis or compositing samples, and now they have data, unfortunately, that cannot back up their story. So in the cost-benefit analysis, it definitely is on the positive side of things. Now, who should pay for it? I can talk about our day-to-day. So I can talk about there are big F&B companies that want to incentivize, or there are even a lot of governmental carbon incentives in Scotland, for example. So there is a range of who pays. Now, who should pay? I think that's more of a philosophical debate, right?
I was just thinking now, you showed that the grassland is actually the best capture of carbon, and now we also yesterday had the presentation saying it's the cow's fault with the methane. So has anyone looked into if having the grassland, which you only have, if you have cow or sheep and so on, if that actually makes it neutral for the farm? I think that could be quite interesting to see.
Yeah, so that's a really good question, and thank you. Yes, right. So as with a lot of things in today's world, there's a lot of kind of like difference in the definition, right? So what is net zero? What is carbon neutral? Right? So when you look at net zero, right, and how we can reach it, you're talking about emissions. So one thing to note is that this should bring together the reductions and the removals for a true net zero, right? So there are studies, there's Arc Zero in Northern Ireland, where farmers have come together, and what they're doing is they're trying to understand this true net zero. So they're looking at below ground sequestration, above ground sequestration, and emissions in the same bucket. And to be honest, there are systems, and there are dairy systems that are actually carbon negative, right? So this is a really, really good question. I think there's a lot on the regulatory side of things and the way we report it, you know, the SPTIs, and there's a lot of work to do there. But you're absolutely right. This is trying to get to a true metric that helps. And the removal side of things, I think, is a really, really important asset, you know, as you say, in dairy industry. When you look at, you know, methane emissions and everything, to try to counterbalance and have a really positive story when it comes to there's grasslands and there's animals in there for a really, really good reason, right? So, yeah.
And to be fair, we're blaming the bacteria, remember? It's bacteria creating the
yeah.
methane. Although the bacteria are necessary in the room, and so taking away the cows. I mean, they're kind of superheroes when you think about it. Like, they are the ultimate plant-based, right? They're taking grass and, yeah, yeah. So, thank you very much for your insights, Dr. Harry. We really appreciate that. Thank you.
Perfect. Thank you very much.